Hi, Jason with Hermetheus Coffee and Coffee Crafters. This is an unscripted video, but I want to talk about something that's going to be a big shock to a lot of people, and that is to stop tracking your rate of rise while you roast coffee. It's getting in the way of you actually improving the quality of your roasts. And if you're a student of like Scott Rayo, who would preach things like always have a declining rate of rise in your beans and avoid at all costs the crash and the flick. If you're a fluid bed roaster and you've let that mindset get in the way of a great cup of coffee, this video is for you. I see far too many people. We have hundreds of customers around the globe that use the Co-Pilot automation device to automate their roasters. So I've helped numerous people for years try to dial in their roasters, and I see one mistake time after time after time again, and that is letting a small crash and flick get in the head of the roaster. They think that their roast is destroyed because they see a small deviation in their rate of rise curve. And so I want to show you why I think that that is a bad metric to look at while you roast. I want to show you what I believe is a much better metric to track your accuracy during roasting. And then finally, I want to show how to enable that metric in the new Artisan 4.0 software, which is amazing. Let me begin by showing a couple of different completed roasts, and I want to specifically take a look at the rate of rise curve. So let's just make the assumption on this that batch size and roast profile, all things are identical on two different roasts, where the only thing the only piece of data that I'm really going to give you here is the rate of rise curve itself. So our rate of rise curve is this jagged line right here. And, Scott Rayo would say that we need to avoid the crash and maybe the flick at the end of the roast here. So let's call this roast number 1. And then let's contrast that with roast number 2 right here. And obviously, there's a lot of data that I'm not giving you, but if the only piece of data you had to go by was the rate of rise curve, which one do you think was the better roast? Would it be roast number 1 or would it be roast number 2? Now, if we look at roast number 1, we see, yeah, it is a little more jagged, but maybe that was just a smoothing thing. But what we definitely see is a more dramatic drop-off kind of in this area right here, and then really a more maybe dramatic increase, and then another really steep drop-off at the end. Whereas if we look at roast number 2, that was much more muted. It was much more tame. So, given these two roasts, roast number 1 and roast number 2, which one do you think was the better roast overall? I hope it's not too controversial to say that roast number 2, if all other things were equal, is the better roast. It tracked more accurately according to that rate of rise curve. Could you at least agree with me on that one? Because if you can, that illustrates the whole problem with looking at rate of rise while you roast. You see, guys, this is the exact same roast. Roast number 1 and roast number 2 are literally the same roast. The only thing I've done is change the rate of rise parameters in Artisan software. It can render as completely different things. So comparing my rate of rise graph to your rate of rise graph is apples and oranges, because we can totally change how that graph looks on our screen. And so it's a terrible metric to look at. You see, rate of rise is not an absolute thing. It is a derivative. And so because it's a derivative, it has a formula that goes, that makes it up. And so in Artisan, we can change that formula. And we don't interact with the formula directly, but we do interact with it indirectly. So in Artisan, we can change things like the delta time difference. So we compare our bean temperature right now to 1 second ago, or 15 seconds ago, or 30 seconds ago. We can adjust that, and that will impact what that graph looks like. We can change our x-axis on our delta graph right here, and the more compressed your x-axis is, the greater those ups and downs are going to appear, even though they're identical. There's also a concept of smoothing. It can take the jagged lines that we see in roast number 1 and turn them a little bit more smooth, like we see in roast number 2. But guys, this is the same roast. And so what I get are some customers that look at something like this and they say, this was destroyed. Like this roast was, completely off the rails. Look at that. Look at that flick that we got. And then it crashed all the way at the end. And then, other people could look at this graph and say, wow, this thing tracks just beautifully. Like I love this thing. So I'm always fighting against trying to teach the concept of rate of rise. And I've decided to give up because I have personally stopped tracking rate of rise in my roasts. I don't even look at it. Rate of rise should only be a design time element that you consider. And what I mean by that is when you create a background curve in Artisan, and I've got a video on exactly how to do that, you should look at your rate of rise. You should make sure that the curve you're creating has a continually declining slope to it. And then you should save that. And now your background curve has a declining rate of rise intrinsic to it. So at that point, the only thing we really need to worry about when we roast is how accurately am I tracking that background roast profile. Now, if you use the Roaster Co-Pilot, we ship it with 28 different profiles. Every single one of those profiles has a declining rate of rise. So that's baked into every profile. If you create your own, you're probably doing the same. So that really becomes the burning question of roasting is how accurately am I tracking that background profile? And that's what I want to show you guys today. There is a way to actually track the accuracy of your tracking according to the background profile. Now, let's first talk about what a reasonable expectation is for tracking performance. So in other words, you've got your background profile in Artisan. It's unrealistic to expect that we will track that with 100% accuracy. I'm not here to give you an absolute, but I am here to give you a little bit of maybe level setting on this. So when we look at what we would call the accuracy of the entire measurement chain of our thermocouple, it begins with the thermocouple itself. How accurate is a thermocouple? Now, in reality, this is just it's not a lab grade thermocouple that we use in our coffee roasters, nor would it make sense to use a lab grade thermocouple in our coffee roasters. But the thermocouple itself has an accuracy of about 99 or maybe 98.75%. So this little guy in and of itself has about a 1% degree of error that is inherent in it. Now, we're gonna take this and we're gonna plug it into our Co-Pilot or our measuring device. And then within your measuring device, so inside the Co-Pilot, there's actually a little onboard thermistor, and every temperature measuring device has a little onboard thermistor, and it feeds it into a little ADC, a little analog to digital conversion. And so we introduce a tiny amount of additional error on top of the 1% or maybe 1.25% that we get out of this thing. And then once we convert this analog signal to digital and we send it to Artisan, it's going to do some rounding. So this thing might produce temperatures to the 100th of a degree, and then Artisan might round that to a 10th of a degree. So when we look at what I would call the overall measurement chain, it's reasonable to say we have between a 1 to 1.5 degree of error. That's the best accuracy we could hope to get out of any single reading is 98.5 to 99%. So to me, that's kind of like maybe the ideal. Like if I see something that a temperature in Artisan that is right on the nose at 100% accuracy, that reading is still, mathematically speaking, probably only 98.5 to 99% accurate. So maybe if I can just get you guys to come on board and say, yeah, I would be reasonably happy if my roast could track at 98.5 to 99% accuracy. And if you would be in this camp that would say, yeah, 99%, I'm good with that. Let's jump into Artisan and take a look at a few things. Now, this is the very roast that we were just looking at the screenshots of, and I'm not showing my delta bean temperature, that rate of rise curve, because I think that gets in the way of things. Instead, I've added this new element, and we call this the deviation percent. Now, the deviation percent aligns with the right axis here. So I have my 0 mark. 0% deviation would be this horizontal line right here, which I've also aligned with the 100 degree mark on my left-hand axis. So 0 degree deviation, or if you wanted to think of it, 100% accuracy, it is the same thing. So let's take a look at this. This dark black line is our background profile. That's what we are trying to track here. And now this new blue line that we've introduced, that shows the percent of deviation that my bean temperature has. It's this blue line right down here from my background profile. So at the beginning of the roast, like every roast, we're not on the background profile. My goal is to be on the background profile by dry end. I missed it a little bit on this one. I admit that. I had a 9.5 pound batch on this one. My roaster was a little bit overloaded, so it was struggling to get up to temperature. So it was just a little bit after dry end that my roast actually caught up with that background profile. But now if you look at the LCD markings over here, I'm just going to move my mouse through this. Once I hit that background profile, look at my deviation percent. I'm at 0.5%. And as I move through this roast here, I overshot by, 0.2%. And then I come back to just, right on the nose and I go down. I'm approaching first crack right now. And you can see my deviation on this roast, like once I was on it, it never goes above 0.5% deviation. Guys, I don't care how picky you are, 0.5% deviation on a roast is fantastic. And that's really all you need to worry about. I want to show something again. That 0.5% deviation has a rate of rise curve that can look like this. Now, this makes it look like a train wreck, but in reality, this roast tracked about as perfectly as you could expect a roast to do. Let's take a look at another roast, Sumatra. Now, the previous roast that we were looking at was Brazil. Sumatra is a little more difficult. All right, now on the Sumatras often, because they're wet hulled, they have higher moisture contents. And so once we hit dry end on a fluid bed roaster, there's more evaporative cooling that goes on. So you can see more dramatic crashes and flicks at the end of the roaster, at the end of the roast. I'm going to adjust my x-axis real quick so it looks a little bit easier to see here. All right, now my x-axis goes into the negatives and it makes this 0 mark align with the 100%, so it's a little bit easier to make sense of. So on this batch of Sumatra, you can see I had an initial overshoot here, a little bit of an undershoot, but by dry end, let's just say I was kind of right on the nose. I have a deviation percent of 0.4%. That's still fantastic. And as I go through this roast, you can see my deviation percent does not go above 0.5%. Now, a Sumatra after first crack, yeah, it's going to be a little bit more difficult. So now we're in like the most active phase of the first crack for this Sumatra. But even at its, what I'm going to say, its worst, my deviation is only 0.7%. Another way of saying is I'm tracking with 99.3% accuracy at the worst point of the entire roast. It never gets worse than that. Guys, that's a fantastic tracking accuracy. I want to show one more piece of data on the graph. I actually want to show the burner percent for this graph, and I'm going to show that by clicking my Co-Pilot percent here. This red line right here indicates the percent of burner power that the Co-Pilot or Artisan's PID was asking for. Look at this dramatic drop-off in the burner percent that happened. You see, Artisan's PID, it's in version 4.0, it's a whole new game, so we can be really aggressive with our p-values. And it was seeing a very slight deviation, 0.7%, and it made a dramatic change in the heat level based on that, and then very quickly came right back. So big difference in the heat. I don't even like to look at my burner percent anymore because that's just a piece of data that gets in the way. Instead, what I look at is my overall tracking accuracy. And when I look at that, this is beautiful. I still stay above 99% accuracy on my entire roast. And folks, I think this is how you need to start roasting your beans. It is a clean, simplified way of looking at things. And this deviation percent is the only metric that you really need to be stressing about. Now, how do you enable this? If you download the Roaster Co-Pilot settings, I'm going to have this already set up for you. But if you're not wanting to load the new settings, maybe you've got a customized version of Artisan. In order to do this, you've got to go into Config Device. And specifically, you need to go to the Extra Devices tab. And here's where it gets a little bit tricky on this, but Artisan knows every input as the letter Y with a number. And by default, and you can't change this, your ET, your environment temperature probe, Artisan knows as Y1. Your bean temperature, your BT probe, Artisan knows as Y2. So Y1 and Y2 are both taken. And then every device on this line right here becomes Y3, Y4, Y5, Y6, so on and so forth. So the first thing that you're going to need to enable is an extra device called PID SV/duty. And I have that on line 1 right now. You have to have this because PID SV is our target temperature. That is our set value. That's the thing we're going to compare where we are against. And so you must have this at a minimum. Now, I have a few other things in my list here. You don't have to have those. I recommend them, but you don't have to have them. But then on line 5 is the next thing that you must have. And for line 5, it's just a virtual device. Now, a virtual device means you can kind of do whatever you want with it. You can build a formula, and then Artisan can display that formula on the LCD panel, or it can graph it in the background, or it can just log it in, like in the data table, and you'll never even see it, but it's a piece of data that you can go back and reference. So by adding a virtual device, you can see I've named my first virtual device as Deviation Percent. This is the one that I care about. And what is deviation percent? Well, it's a very simple formula. We take our target temperature divided by our error, our percent of error, and then we take that times 100 to get a percent. So this is the formula that I have right here. So it's Y10 divided by Y3 times 100. Now, why is it Y10 divided by Y3 times 100? Well, remember, Y1 and Y2, that's our ET and BT temperature. So that's Y1 and Y2. That means that this row right here gives me Y3, Y4. This is Y5, Y6, Y7, Y8, Y9, Y10. So this PID error right here, Artisan knows it as Y10. And thus, I've got Y10 right here. And then I'm going to divide it by Y3. Why Y3? Because we've got Y1, which is ET, Y2, which is BT, and then this PID set value, that's our target temperature right here. On my setup right here, it's Y3. So I take the percent of error, divide that by my set value, take it times 100, and then that ends up being a percent. Now, that'll calculate it. Do you want to show it on the LCD panel? If you do, check this little box right here. And you'll notice if I uncheck it, it disappears. Now, do you also want to graph it on your screen? Absolutely you do. That shows it to us visually. And so I'm going to check curve 1. And then finally, I personally like to align this with the delta axis. And so I check that box here. What that means is my values are aligned with this axis over here on the right. Why do I do that? Because our left axis has a scale that goes from like 0 to 500. It's not very granular. And when I do my delta axis, and I make it go from -10 to like 40, it makes the line responsive enough. And so any deviations in that line are fairly easy to see. So if my goal is to keep this under, say, 1.5% error, I have, my axis shows the 0 degree mark right here. I know that 2 is right here. So basically, if this blue line is staying within the bounds of 2 to -2, I know I'm in the ballpark. And guys, this is how I now roast. I do not look at my rate of rise. I don't even really look at my burner temperature. This gives me a nice clean layout. It reduces my stress while I roast. And as long as these values are staying within like 1.5% accuracy, I call it a day and I'm off to the races. I hope you can do the same and that this actually improves the quality of your roast, but also the quality of your mind as you roast. Thanks so much.